So we're going to talk about planes in 3-space. So a plane is described to be, it's just, well, I kind of draw a picture like this. So you have some sort of a plane. It might have a point P naught on the plane. And then the plane is said to have a normal vector, ABC. And so that normal vector is a vector that is perpendicular to the plane. And so if you wanted to write down the equation of the plane, you could have the point P naught, which is x naught, y naught, z naught. And then you have the normal vector, which we could write as ABC. And so this plane is defined to be all of the tips of vectors that are based at P naught that are perpendicular to n. So it's defined to be all of these vectors that are pointing, in all these different directions that are perpendicular to the vector n. Okay, so if I want to write down, so if it consists of those vectors, we know that if vectors are perpendicular, their dot product is 0. So the way that you could write this down is you could say that it is all the vectors whose dot product, so for any x, y, z here, for any point x, y, z, we have x naught, y naught, z naught, right, over here. And so I could make a vector between those two. So the vector between those two would be this vector, x minus x naught, y minus y naught, z minus z naught. So that's going to describe any of these points x, y, z in that plane. And I want it to be such that when I dot that with the vector ABC, I get 0. And so from this is how we're going to come up with the equation for a plane. So if I take this idea where I've taken this vector dot ABC, I need that dot product to be 0 because I want those blue vectors to be perpendicular to my normal vector. So if I go ahead and do this dot product, I'm going to have AX minus AX naught plus BY minus BY naught plus CZ minus CZ naught equals 0. And then I can move all of these guys here are just going to be constants because x naught, y naught, z naught, I'm going to actually have numbers for those values. That's actually a point that I'm given. And then I might have number values for the vector ABC. So those things that I highlighted in yellow are just constants. So we can move those over to the other side. And so I get AX plus BY plus CZ equals, and I can move all those things over, AX naught plus BY naught plus CZ naught. And sometimes we want to just subsume all of that and just say all of that is going to be some constant. So I can say this is AX plus BY plus CZ equals D. And so when I think about, and another way you can write this is you can write this as the normal vector dot with XYZ equals D, some constant D. And the way you could find that D, if you didn't know, is by doing AX naught plus BY naught plus CZ naught. That's going to give you what that D is equal to. Okay, so this way of writing the equation of a plane is called the vector form. This way is called a scalar form. This way and this way are both called scalar forms. So these are all different ways of writing the equation of a plane, and they're all equivalent to one another, as we can see. So say, for instance, I knew that I wanted to write an equation for a plane going through the point 3, 1, 0 with normal vector n equals 3 to negative 5. Okay, so say I want to write that down. Well, all I do is I can just plug it in. So I have, so I know that my, so I'm going to have, I'll write it using this one. So I'll have ax plus by plus cz equals ax naught plus by naught plus cz naught. So I'm just going to put those in. So this is my ABC, and this is my x naught, y naught, z naught. So I can just plug those all in. So I'll have 3x plus 2y minus 5z equals, and then I'll have 3 times 3 is going to be 9 plus 2 times 1 is 2 plus negative 5 times 0 is 0. So I'll get 3x plus 2y minus 5z equals 11. So that's the equation of that plane. Now, one thing you might notice is that if two planes are parallel to one another, what does that mean about their normal vector? Well, they're going to have the same normal vector. So parallel planes have the same normal vector. Well, it could be scaled, so up to a scalar. So in other words, I could say like this plane here has normal vector that's like, half as long as those normal vectors, but it's going to be pointing in the same direction. So let's say that we have 3 points. So how can we find the equation of a plane through 3 points? So what we found before is that to write the equation of a plane, we need a point and a normal vector. Well, if we have 3 points, we definitely have a point. So how could we get a normal vector out of those 3 points? Well, you're usually given points, P, Q, R. So one thing you can do is you can use those points, P, Q, R, to just make 2 vectors. So it doesn't matter which ones you make. So you might make PR and PQ. So you make vectors. And PQ. And so you can just do those by taking the, the coordinates of R minus the coordinates of P, and that'll make a vector. The coordinates of Q minus the coordinates of P, and that'll make a vector. And then you want to dot product, or not dot product, cross product, excuse me. So you want to take the cross product of these vectors. And once you do that, that's going to create a normal vector. Now, it's hard to draw what direction this is going because really it needs to be coming out from the screen. But when you cross those two, you get a vector that is perpendicular to both of these vectors, right? And so, so you're going to get a vector coming out of point P that is perpendicular to both of those two. So that would be the normal vector for the plane. So once you have the normal vector, you can just use one of the points and write the equation like that. Okay, what if you want to find the intersection of a plane and a line? Well, so to do that, basically you're just going to be plugging things in. So if you have, the equation of the line, maybe you solve for one of the variables and you plug it into the equation of the plane, or vice versa. Similarly, if you wanted to find the so you're just going to solve the system of equations. So you're just going to take, the equation that you have for the line, maybe solve for one of the variables, or if it's parametric, you can just plug it straight in, solve for that, and then go from there. So that's should be pretty straightforward. let's see if I can find a quick example. So if you have, find the point P where the plane 3x minus 9y plus 2z equals 7, and the line r of t equals, so it's going to be 1 minus 2t, 2, and then 1 minus t. Okay, so we want to find the intersection of those two. So basically what we're going to do is we're going to take that, plug it in for x, that, plug it in for y, that, plug it in for z. We're going to solve for t. So we're going to plug those guys in over here, solve for t. And then to find, that's going to give us a value of t. That doesn't give us a point. We want the point would be, x, y, z. So what we would need to do is then plug that in to the equation of that line, r of t, to get the point that we need. So pretty simple. Okay, I'm going to stop there.